Welcome to the night sky for June 2025. I'm Adam from the Wellington Astronomical Society, and in this presentation we're going to look at our moon phases and planets as usual. We've got an interesting occultation later on in the month, and then we're going to talk about auroras and finish off with our usual night sky stellarium tour. Let's get started. First of all, the moon phases. We have our first quarter moon on the 3rd of June. Full moon is on the 11th of June, which is apparently full of strawberries. Well, that's because it's known as a strawberry moon by Native American people because it marked the strawberry harvesting season. So now you know. The interesting thing about this month's full moon is that it reaches the highest altitude in the sky in the southern hemisphere, so this is the brightest, highest full moon that we'll have this year. Then we have the last quarter on the 19th of June, then finally the new moon on the 25th. Turning our gaze to the planets visible at the moment, we have Mars fairly low in the western evening sky. At sunset, it's around 30 degrees above the horizon. Of course, it's following the sun as it sets. Early evening, just after sunset, is then the best time to look for Mars. Jupiter is also still present in the western evening sky, but it's very close to the sun by now, so you're unlikely to see it. Very low on the northwestern horizon straight after sunset, and it will set only 1 hour after sunset when there's still light in the sky from the sun. If you've got a good view of the western horizon over water, perhaps you might be able to see it, but it's not optimal viewing conditions for Jupiter at the moment. However, early in the morning we have Saturn and Venus as early morning targets high in the northeastern sky. Turning to the occultation, this is where we have a bright star or a planet going behind the moon, or more accurately, the moon passing in front of it. Anyway, it's anything occupying the same piece of sky as something else at the same time. So the moon and Antares are fighting over the same piece of sky, and temporarily at least, the moon is going to win. Now, despite the moon's near full size and brightness, Antares is a bright first magnitude star, meaning this occultation should still be very visible. You can look for it in binoculars at the very civilized time of 10 p.m. to 11:40 p.m. on a Tuesday night. From Wellington, Antares will disappear and seem to go straight through the center of the moon, making this a really good one to look for. Moving on to auroras, there's a lot of aurora activity happening at the moment, so I thought it would be a good idea to just talk about what actually are auroras and what's causing them. So the visible auroras are caused by disturbances in the Earth's magnetosphere, which are charged gases high up in the atmosphere. The disturbances are caused by the movement of charged particles in the upper atmosphere, and those particles are moved by the solar wind, which is in turn caused by coronal holes and coronal mass ejections from the sun. The sun goes on an 11-year cycle of activity, and right now we're at the very peak of it, known as solar maximum, which is why we've got all these auroras happening. At solar maximum, auroras can happen anytime. So there's a Facebook group for this, Aurora Alerts. We'll link to that on our Facebook page. So if you do visit that group, note carefully the terms and conditions. It's just for notifications. It does not invite commenting or publication or photos of anything like that. It's just purely a notification group. There's also the Aurora Geomagnetic Activity Level Index website, which will show you the current geomagnetic activity level. And numbers above 5 typically indicate promising potential for aurora activity. Here are some photos I've harvested from various media which show the different auroras and how they're presenting as people are photographing them. You'll definitely get some good opportunities to see the aurora if you can get somewhere with a dark southern sky view. Use the long exposure photo feature on your phone or use a conventional camera as long as it allows manual adjustment of exposure. Brace the camera against something stationary so you can hold it still for the entire exposure or just use a tripod. Definitely experiment until you get the best results. Now let's take a look at the night sky stellarium tour. It being June, of course, we have Matariki. Before we look at anything else, let's have a look at Matariki. So Here we are on the 20th of June, which is a Friday. It's Matariki Day, and right now we're at 4:30 a.m. Let's advance the time slowly. You can see the clock on the bottom right of the screen. You should start to see the Matariki constellation just underneath Venus, just starting to rise. And zooming into it, there's our familiar grouping of stars. They're only very low above the horizon, and as the day progresses, the sun comes up and washes it all out fairly quickly. So it's a wonderful time to celebrate Matariki, and coincidentally, it's also the worst time of year to actually view Matariki. If you want to view it when it's at opposition, which is the best viewing time for it, then you'll have to wait until late November. Anyway, jumping forward until 6:15 in the evening on the same day, Matariki Day, and we're looking in the northwest now, where the sun has just set. It's 6:15 in the evening, and here we've got Mars, and as we advance the time, Mars continues towards the horizon and finally sets at around 9:30 p.m. Swinging around to the east and coming round to about 12:30 in the morning, we've got Saturn just starting to rise, and then we have the moon rising behind it, and then Venus. So Saturn and Venus will definitely make good early morning planets to view, and we can see that they actually get to a good altitude above the horizon before the sun comes up. Coming back around to the north and coming back to 10 p.m., if we turn on the constellations, we can see the anti-solar point here, surrounded by the familiar winter constellations of Ophiuchus, Sagittarius, and Scorpius. Scorpius is a particularly easy one to see, and if we turn off all the constellations, you can still see it, because you've got this bright red star here, which is Antares, one of the brightest red giant stars in the sky. And you've got this kind of asterism of these three stars, almost like a parenthesis or brackets or a semicircle, with Antares at the center. So that's how you can find the winter scorpion. With Sagittarius, which is the constellation closest to the anti-solar point on this here, as we're looking at the moment, if you look at Sagittarius and kind of try to look through it to the heart of the Milky Way, you're actually looking right into the center of the galaxy. If we zoom out a bit, you can see that at this time of year the Milky Way is quite a magnificent sight, stretching from kind of northeast, going almost overhead, and running to the southwest. The Milky Way is an excellent target for wide field photography. You can capture it with a phone if you use night mode on your phone and wait until a moonless night, and you can find somewhere dark to get the maximum effect. Coming back to the northern horizon, you can see that fairly low we have Arcturus. Arcturus is worth looking for because it's a fairly bright and visible star, around 170 times the luminosity of the Sun, and as we observe it, our atmosphere often causes the star to twinkle or seemingly cycle through its colors, particularly when it's quite low to the horizon. Swinging around to the south and looking up high into the sky, we can see our familiar Southern Cross, which has now moved over to the western side of the South Celestial Pole. So of course it will advance clockwise around that as the evening progresses and as the year progresses. But the bright stars in this part of the sky are Canopus and Achernar. And at this particular time, 10 p.m., they're quite low down to the horizon. But these stars are circumpolar. Now what this means is that they will never set day or night. They are always up. Let's explore this by first turning off the atmosphere so daylight doesn't bother us. Now looking at Canopus, let's grab hold of the time and just slide time around. You can see it almost touches the southern horizon, but not quite, and then it comes around. And then, of course, daytime happens, and because I've turned the atmosphere off, the stars are still visible. And Canopus just continues to revolve around the South Celestial Pole, never setting, never going below the horizon. So this is why it is known as a circumpolar star. And in fact, you can see quite a lot of the stars around the South Pole, like the Southern Cross, for example, and Achernar as well, all circumpolar. Anyway, that's all we have for you this month. Happy observing, and thanks for watching.